A standardized value, like a z-score, kind of shows you how people are doing relative to their peers, relative to the people who are being surveyed or asked. First, I want to give an example of how I learned how to do z-scores. If you were given a lot of data, and I'm just going to use some data from the book. Okay, 6, 7, 72, 73, 73, 74. They break this up to 75, 77, 77, 78, 79, another 79, 80, 80, 81, 82, 83, 83, 83, 84, 85, 6, 89, 90, and 93. Let's do a mean of 80. And a standard deviation of 6.07. And this I'm just copying from page 89, this chart. Okay? How I visualize this is every standard deviation is a score of 1, a z-score of 1. So if I think of what the mean is, then typically if you add the standard deviation to it, around 86 we'll get a z-score of 1. If you were to add it twice, 92.14, around 92.14 should be a z-score of 2, and so on. And you can go downward as well from the mean. If you take away the standard deviation and you go 1 standard deviation away from the mean, you'd end up at about 73.93, something like that. And that should be a z-score of -1. And again, if you wanted a z-score of -2, you would take 2 standard deviations away from the mean. Oh, I don't have my calculator, but I'm assuming it's like 67.86 would be around a z-score of -2. So that's how I visualize it. Like if you're 1 standard deviation away, or you're your z-score is 1, then you're like 1 whole standard deviation away from the mean. And if you're positive, you're going higher. And if you're negative z-score, you're going lower by standard deviations. The formula to calculate a z-score is z equals the value you're using minus the mean divided by the standard deviation. Okay, my pen died, so hopefully you get to the second part, or that you went and listened to the first part as well, where I built the table and so on. But if you try to use my little method over here in this little z-score formula, like for example, let's say we were trying to find the z-score of 80. Okay, well 80 is the number we're looking for. It's also the mean. Divided by the standard deviation, we'd end up with 0 over 607. It would be 0. So the z-score would be 0 for the mean, because it's not to the left or to the right. It's right on target with the mean. If we were trying to find a z-score of, let's say, 86. 86, take away the mean, divided by the standard deviation. It should be approximately 1. I think when we actually divide it, we're going to get 0.99. but it should be pretty close to 1 because it's 1 standard deviation away from the mean. And it's a positive direction. If I were to go the opposite direction, 73.93, take away 80. Oh, I don't want to do that because there's no number 73.93. I actually have to pick a number from the table, 73. Take away 80 divided by 6.07 is 7 divided by 6.07. And we said 73.93 was around -1. So, oops, -7. And hold on a second while I calculate this. And that works out to -1.15 around. I always change these because I don't like to put equals if I'm rounding. Around 1.15 negative direction away from the mean. So that's how we'll be calculating standardized value, or z-score. So if we take a look up here and we try another one. Let's try for the lowest value, 67. 67 is going to be in for our x value. 80 is the mean. -13. And it's going to be rounded. And this should be like -2.14. So down a little more than 2 standard deviations from the mean. This is what is called to like standardize the value. So you can compare things from previous years. So let's do another example. And we're going to do the year, the player, home runs, the mean, and the standard deviation. So in 1927, Babe Ruth hit 60 home runs. In 1961, Roger Maris hit 61 home runs. In 1998, Mark McGwire hit 70 home runs. Barry Bonds in 2001. Didn't he get busted for something? Performance enhancing drugs or something. Look at that, 73 hit home runs. So when you first look at it, you'd say, okay, well, of course, Barry Bonds was the best out of everyone. He hit the most runs in a single season. But let's compare it by looking at the history of baseball. Some eras have been easier. It's easier to hit a home run in some eras than others. It could be like the baseball, the hardness of the baseball, the pitchers, the dimensions of ballparks, and of course, what I was just saying about Barry Bonds, drugs could enhance things. So maybe Babe Ruth was not using any performance-enhancing drugs. If he did, maybe he would have scored double. Who knows? Or maybe even 20 more and beat everyone. So to compute, we're going to compute standardized scores for each performance because we're going to look at what the average is. In 1927, it was about 7.2 in a season. 18.8 in 1961, 20.7 in 1998, 21.4. Maybe everybody's starting to use performance-enhancing drugs because the mean for everyone is getting a lot greater. And the calculated standard deviations are as follows as well. And that data I'm just going to give you, the mean and the standard deviation for that era. So let's try to calculate each person's z-score. So for Babe Ruth, he got 60 home runs. Take away the mean. So he did a lot better. By the standard deviation, he did a lot better in comparison to the people around him. So that works out to around 5.44. Roger Maris got a 61, but people around were doing a little bit better. The mean score, or the mean average was 18.8 for home runs for all the players, and the standard deviation is 13.4. I'm going to work on this in a calculator. So I got about 3.14 when I was calculating this one. I think it was 3.149. I should have rounded it up, but Mark McGuire, he got a 70. The average around him was about a 20. 12.7. I got about 3.88. And Barry Bonds. So he did the best out of everyone, it seems like. But people are doing better typically as well. 50. About 3.91. So, in essence, what this is kind of showing us is when we standardize and level the playing field with the era or the year that this was occurring, you can kind of tell who is superior. And it was the first one that we were doing. So everyone was doing really good, but Babe Ruth really can still be the person who says, well, he's not saying anything right now, but he can still be the person who people claim to be the single season home run champ. Definitely. And now you have the data to prove it.